In today's lesson, we will continue to work with compound interest, but instead of focusing on finding the future value as you did in your homework for the past lesson, we're going to look at trying to find some of the other variables in that compound interest formula. So finding present value, and then in class we'll be finding the time that it takes for something to grow, or the rate at which you would need in order for it to grow. So let's just take a look at finding present value in this video. Our problem is, how much should you invest right now at 10% to have $8,000 toward the purchase of a car in 5 years if interest is going to be compounded quarterly? So our key information here is that we have 10% interest, and again we assume that is annual interest unless we're told differently. We have $8,000 that we want to have in 5 years. So this is not the money that we are putting in right now. This is what we want to end up with. And then we need to recognize that we are compounding this quarterly. Okay, so this 8,000 represents our A. That is the amount we want to end up with. This, being compounded quarterly, represents our M, which will be 4. We'll be compounding 4 times in a year. The 5 represents our T for 5 years. And the 10% represents our R, which is a 10% annual interest rate. So when we put this into our equation, because we are compounding quarterly, we actually need to use the A equals P times 1 plus I to the N formula. So the A we have, that's going to be the 8,000. The P is what we're trying to find because they want to know how much should we invest now. The 1 is constant. I, remember, we get I from taking rate divided by the M. So in this case that means taking the 0.10 divided by 4, which means I is going to be 0.025. So that's what's going to go in here. And then N, remember, comes from taking the number of years times the number of times that we compound in each year. So that's going to be 5 years times 4 times a year, which will give us 20. So our exponent here is going to be 20. Okay, so now we can start plugging things into the calculator. I would suggest that we start right here. Taking the 1 plus 0.025, which is just going to be 1.025, and raising that to the 20th power. That ends up giving you a value of about 1.6386, and the decimal continues from there. And as I mentioned in class, just keep that decimal in your calculator so that on your next step, when you actually want to divide both sides by this number, the 1.6386 whatever, that you can actually set your calculator to go 8,000 divided by previous answer. Now you have to kind of figure out where that is on your calculator depending on the type of calculator you have. But most scientific calculators have a way of reusing the previous answer. So that's what you want to do here to keep things as accurate and as exact as possible. So type in your 8,000, then divided by, and then previous answer. And when you do that, you should end up with a p-value that is 4,882. And then it goes on 0.1675 and so on and so on. We're rounding to the nearest cents because we're talking about US dollars, so that's going to round off to 17 cents. And that is the amount you would have to deposit now in order to end up with the $8,000 you want in 5 years to help you purchase a car. So this is just one example of using our compound interest formula, but for finding one of the other variables. Okay, this was a case where we had the A in this case, and the P is what we were trying to solve for. In class, we'll be looking at situations where we're trying to solve for the rate or for the amount of time, and we'll talk about how to solve for those variables when we get together in class. And so until then, make sure you take good notes over this, and we will see you next class.